Okay, great. Yeah, can you guys see my screen? Oh, good. Yes. Well, yeah, thank you everyone for joining us on this third meeting of the CBIA. Yeah, really happy to see all of you. We have a really exciting topic to talk about today. Last time it was about Hydra and the Hydra team. I wish we actually had recorded this one, but this time around, I think we'll try to record this one. And that's actually what's going to be the first on the agenda is make sure that everyone is okay with recording these meetings. Since this is like a group organization, I don't want to make like executive decisions, but just to double check, yeah, like make a record and then publish this to YouTube. Like we are domain experts, we are talking about subjects that we talk about on a day-to-day basis, but I think the community could really learn from hearing about those discussions. And obviously it's great for us to get more eyes on what we're working on and hopefully maybe convince other developers to get involved into these projects. So sounds like yeah. So and then the second thing on the agenda is yeah, Chris and Andrew talking about the Go library, the Go client for Ouroboros, and some of the challenges and things that they worked on. So that would be like the main bit of the presentation. And then at the end, I think we had like one action item from last call. So we'll just kind of sync up on that, and then we can also decide on further action items for next call, or maybe discuss on future subjects or topics that people want to cover. So first thing on agenda. So yeah, it sounds like I saw a lot of thumbs up. So it sounds like everyone's okay with the recording. And so if we're okay with that, then I'll start it now, and then we'll go from there. So no objection. Let me see how I can record. Get started, and yeah, go with the next topic with the Gouroboros. Chris, do you have anything you want to share, or how do you want to do this?
Yeah, let me share this window.
Go for it.
Hey, all right. Let's see. Can you still see it?
Yes.
Okay, yes. Cool. I wasn't sure. Went full screen or whatever. All right, so this is about us and our experience with building Gouroboros, which was the Go Ouroboros network library. So who are we? We're Blink Labs. Andrew on the line with us is lead engineer, wrote most of Gouroboros, and me, the CEO. So what is Gouroboros? It's the Ouroboros network protocol in Golang, right? So we wanted to write implementation in Go because that's what we're familiar with. So this is, again, about our journey in getting that done. So first off, why would you do that? This was a question that we got asked seriously when telling people at Rare Bloom what we were doing. And, there's the usual suspects, right? Cardano DB Sync. Everyone that's done anything with DB Sync understands that, it can be finicky, right? At best. Everything being, or things being written in Haskell. Right, and our familiarity with Golang. Some of the issues with using things with Unix sockets and you having to do workarounds with like SOCAT to be able to communicate with nodes, like data storage of information out of the ledger, and then node monitoring. Oh, and finally, transaction submission. So a lot of the challenges, were around there being essentially a single implementation of a lot of these libraries and things like that. I'm not sure Santi and the guys from TX Pipe know, like going back in and reverse engineering a lot of these in a lot of cases required a decent amount of work, going and doing things like running through and running a packet sniffer while performing operations to see what the packets look like, trying to pull the CBOR out of it, decode it, things like that. So as we were going through and doing this stuff, we found through implementation that there were a lot of CBOR data structures that were incompatible with Golang. Andrew, could you give like a couple examples of that?
The most prevalent example is a map with a byte string key. So Cardano likes to use over, and especially byte string keys or byte strings are used all over instead of just typical strings for things like asset names and whatever. And then if they end up being the key in a map or a dictionary, Go just cannot deal with that because a byte in Go, that byte string becomes a byte slice, which is not hashable for various implementation detail reasons in Go. But so we cannot parse natively into Go data structures, some of these CBOR structures. Right. Another one I've run into more recently is actually a CBOR tag as a map key, which is its own problem, but can be hand waved around, with some effort. But yeah.
Right. So it meant that it was difficult for us to marshal and unmarshal, the CBOR into native Golang structures as we were doing this. Aside from that, there were a lot of undefined data structures. Again, like in the reference implementation, the biggest ones that we've run into are like protocol errors and things like that can be era dependent. They can change over hard forks sometimes, and then they're also nested in a lot of cases. So instead of getting, just like a single error, you'll get all of the possible errors, and there's differences in ordering and things like that. And all of this is essentially undefined. In the current state of stuff, it works okay because there's essentially a single implementation for most of these things, all sharing the same libraries and things like that. So these decoding is easy within Haskell. But as soon as you move to other libraries or other languages, we have to figure out and basically reverse engineer, a lot of these data structures. So along with that, there's other things like implicit behaviors in the reference implementations that aren't mentioned anywhere, especially timeouts. There's like packet rate thresholds. What other kind of interesting stuff did you find? Like there was some stuff with the muxers.
The timeouts and thresholds were most of it. And a lot of that is the Ouroboros network spec mentions that they exist, but has zero details about their actual values. And so you have to actually go to the Haskell code to find the actual values for each mini protocol in node to client versus node to node, and all the potential combinations of modes and factors.
Right. And then another issue that was common as we were writing the library was insufficient communication on upcoming changes. So, we started this a year and a half ago, and since then we've had hard forks and like node upgrades and a lot of other stuff that's come down the pipe, and a lot of it was not well communicated ahead of the time of what changes were actually going to be necessary. So we essentially had to wait for them to be released onto like public testnet and stuff like that, and then just go find out ourselves, sometimes going back to step one of undocumented protocols and packet sniffing even. Now I can say that this has improved greatly, but so yes.
One quick question. What was the scope again, what you kind of were dealing with? So I briefly saw node to client somewhere, sure, and node to node protocols, or like all of them or parts of them. I heard error cases, probably then it's about the transaction submission errors or something like this. Maybe can you about which content, not only about what
Yeah,
the problems on the.
absolutely. Yeah, so let me just kind of go back here. We'll come back to this in a minute. So we started just with ChainSync, right? Essentially as the starting point that we were looking at. So we went node to client and node to node. ChainSync were some of the first things that we were trying to implement, and then local TX submission. We eventually got Catalyst funding, and we had the funding was for implementing all of the node to client side. So we've implemented all of node to client now. There's a few things still, like where, for example, the local state query is not well defined either. So there's a lot of cases where we know that we get a message for local state query, but we've not yet fully decoded it. So there's a lot of places like that where, like as Andrew had said, where the spec will say something like there's an error here, or there's an object here, and then doesn't necessarily describe what the object it looks like or is shaped like.
Thank you. That answers my question already a bit. Thank you.
Yes. Santi.
Yeah, and I agree. I had to go through the same issues in the Rust client, the exact same issues. I think that some part of that is by design, so that Ouroboros as a protocol, it's decoupled from the specific Cardano ledger implementation. But the problem is that for the Cardano ledger, there is no CDDL. There's nowhere to be found, and I asked for it even, and I think that the only source of truth is the actual Haskell code. So local state queries, the error messages,
Right.
even I think that the header content and the block content of the ChainSync, those are also kind of stuff that you have to dive into it and see what you find.
Yeah. And a lot of times it was exactly that, like running ChainSync up until the point that we hit something that it doesn't work on, and then it would break, and then we'd have to go and try and figure out, and at least then we would know a block number or whatever, right? Like we would know where it broke, so it was easy for us to be able to reproduce. But there was a lot of not knowing until we hit it.
Yeah, it's a bit of a multi-level thing, right? So the client protocols, or like also node to node, are basically using this type protocol kind of thing, right? We have like this state agency going from server to client and so on, stateful protocols. And what is actually communicated over it is kind of defined in the protocol there, but there's also versioning, handshaking, and then the content, the actual thing translated. I think you just said, Santiago, you said ledger CDL is not defined. I think that is quite defined, the types you would see there, but probably the messages
you're
around
right.
And so on. Yeah.
Sorry, yeah. I think what I meant was that the Cardano ledger is decoupled from the Ouroboros client, but you're right. The CDL for the primitives, it is to be found, but the intermediate typed structures, such as the local state queries, are not. And also,
The
as you mentioned, versioning.
Yeah.
And the versioning is also another dimension that I still don't fully understand. I don't know, Chris, if you, Andrew, if you've gone through that and have a specific document that I can read, but which local state queries match which version of the handshake, that's also something a little bit mysterious.
Yeah,
It's not well researched on our side. I found that there's some automatic API documentation generated from the Haskell code, and one of the things I found useful is the actual object for node to node version and node to client version. It shows you all of the possible versions for each of those and like what was changed in each of them. And sometimes it's added this query for local state query. So when you do the handshake, like in our library, we have a version map and just some booleans. It's like a bunch of features that we know we're added. So it's, oh, at version 14, set this to true now. And so if we handshake that, we can go check it and say, oh, is this thing enabled? Okay, allow it if we see it. I mean, that's, but yeah, it's just, that documentation is all I've ever found.
Yeah, I think in some cases it's also that there is documentation and it might just be really hard to find. Like for example, I just recently found that now all of the mini protocols, there are CDDLs for them, but they're like buried, right? Like way down in Ouroboros network, and like each one is in its own directory. You know what I mean? Like buried into the protocols and things like that, to where it's difficult to find them. And so that's definitely like an easy place, for essentially, I guess, someone that would be developing on the protocols, right, without developing in Haskell, right? Like most of the stuff is making the assumption, that either the documentation is in the Haskell buried, in various places. So it makes sense if you understand the code base where the documents are, but they're not under a documentation directory sometimes, things like that, or easily findable. And then, as we said, a lot of the structures and errors and things like that are essentially, the documentation is the one implementation. And there's a lot of stuff where, as you said, it's not defined in the protocol, but because everybody's running the same node, it's effectively how the protocol works. Whether or not and that's what I meant by a lot of the implicit behaviors that we get, is because there's only the one Cardano node, certain communications work across the global network a certain way because there's only one Cardano node. Whereas like it might not be specified in the protocol, but a Cardano node might be too strict or too lenient around certain things that we might want to change. Like as we said, some of the stuff was like the timeouts and rate limits, things like that, like how many specific message types you can send in a period of time, right? Like those things might be adjustable for certain use cases, or that sort of thing, where it's not defined, but it does matter. And that's where things get hard, is where, like effectively it matters, but at the documentation and at the design and inception, it wasn't supposed to matter. So, going through recommendations, right? First off, utilizing some of the data structures which are available in more languages. I know that's kind of the issues that we ran into were Go specific. But if the data structures we're passing on wire are hard to translate into other languages, that just makes it that much harder to do things. As we talked about already, like a lot of these implicit behaviors, data structures, things like that, having them documented, especially anything that's passed again over the wire, like the error messages, like the error CBORs, that sort of stuff would be great. All of the mini protocol documentation, like I said, that's been greatly improved already, but seeing that, and then like this, engaging community teams and work groups, which again we're seeing improvement on, and seeing that we're all moving in the right direction. But these are definitely the recommendations. And in fact, I have one that's not directly related to this, but as an example of something is there's a where is it here? Give me just a second. There is a Cardano DB sync bug here that would be something perfect. Issues. Yeah. So like something like this, which is reported by the Koyos guys. And it's essentially, like what should DB sync be working on? Or what should the DB sync be working on, right? And, who are the users in the community? That sort of stuff, like the infrastructure providers, Gimbal Labs, Maestro, Blockfrost, right? Like all of these guys, like almost everybody's building stuff on top of DB sync. So it's like who's building what and who needs what, and establishing that two-way communication, right? Because in a lot of ways, a lot of this stuff does feel like we end up with a, single one-way unilateral communication, right? Even as I was talking about with some of the node changes, as they've made changes into the protocols and things like that, we were able to figure it out, but it was through packet sniffing and this sort of stuff, instead of saying, hey, we're adding this protocol, here's how it works, right? So that all of the community members that have built on the existing stuff can easily adopt it. And sometimes you hear it's like, oh, well, it's like we built it in public, and it's like, okay, yes, but there's 140 commits to, Ouroboros network and Cardano node and this and that, in a week, or, so it's very difficult to keep up with everything that's going on. So trying to better establish those lines of communication between work groups and, the people writing the code and doing the commits.
I would like to kind of hook into this a bit, right? When you were kind of about, of course, I think that most of these things are kind of true for very much all of the stack, right? I mean, often kind of the implementation makes the interface. We see that also in Bluetooth, and kind of be upfront what does, I mean, don't need to standardize if you're the only one kind of using it, and this is the only SDK kind of using it, right?
Right.
And so that is of course true. One thing which just sprung into my mind when you were kind of now back again onto networking and network stack, right, was this, there was this one protocol which was not created by the network team, but by Matthias. And it was the extended, or was it a local chain? Some kind of
local
monitoring.
TX monitoring.
Yeah,
exactly. And this was a SIP, or I believe this was even a SIP first, but he also kind of paired it up with an implementation, right? But kind of ticking all the boxes which are currently there, right? But not kind of going more than like, okay, this is more the spec here, and this is what I would like to build, and so on. But more like, okay, this is a protocol which could be helpful, and also just deliver by implementing it in Haskell.
Yeah.
But that is something which is maybe a good example where it kind of still does work against all the odds, right? That
oh yeah, for sure.
Yeah.
Yeah, I mean, it is good seeing, all of the SIP stuff that have gone in, and in fact, that's what I was saying, is some of it has been super easy because it is very well documented, very well, interfaced with the community before it gets added to the node. And when that happens, it's very, very smooth. It's ridiculously easy for us to go and do things, right? Like the Vassal hard fork was very, very well communicated and tested versus prior to that. And again, I'm talking 18 months is when we started this. So, a lot has changed. Communication has improved all around. But it was, some of the changes early, were like much more difficult to accommodate for, because you had to wait for the node to be ready, because even the preview, like not preview, but the testnet things, they were still changing. They were still iterating. So it's like, you couldn't go and build your mainnet code ready for it until it was ready. And by then the node was done. So it's like, you don't really have input then. You're waiting for, the implementation to be finished so that you can start going, what happens if we find problems, or, like have recommendations. Hey, look, in practice, this works better. That loop is gone, right? And again, that's vastly been improved, I feel like.
What resources were most useful, or what you have been using? You have been alluding to, or there's this auto-generated documentation, or there's something else. Maybe do you have a collection of kind of what is the material which kind of could become a standardization foundation, right? Or because probably there's this very old PDF, right, which is kind of the write-up and so on, but this is probably not up to date, very much likely. And what would then be the standard node to node and node to client, and let's say Cardano networking protocol, right? If you would need to standardize this now today, we have a Rust implementation here from Santiago, we have a Go implementation from you guys, and how would we write the standard, right? And what if you guys now, you two decide, now this is something else, this is on what we kind of interpret this way, right? How would we kind of then and what document would we communicate that with the Ouroboros network team, for example.
Right. So take Santi, go ahead.
No, I was just going to give my opinion for an answer to that question. I think that interface-driven design, where you first define the interface and then you define some benchmark and some testing around that interface, and then with that spec, you let other parties just implement it and make sure that they are compliant with that interface. But I think that Chris was right on the spot when he mentioned that since this is only a team that is working on a single implementation, then there is no need to define an interface first and then an implementation, because it's just the implementation. I think it's a mindset change rather than a huge change in procedures.
Yeah, I mean, I would agree with that. So, you know, the answer to that would be the Ouroboros network, you know, code base, right? Would be the right place. That's where it's already been started. So, you know, I think the answer would be make sure it's updated, make sure the undefined or, you know, poorly defined or underdefined places, you know, are defined, and ask for feedback from there. Right. You know, no one's saying that, you know, it's like, oh, we want you to completely change how everything goes. It's really just a case of how can we both work together to, you know, like if we have better documentation, you know, if we can find pain points, things like that, you know, and point them out so that we can collaborate on making sure that there's better documentation. You know, even going and taking some of this stuff and including, you know, like the Go and Rust implementation details and pointing them out, you know, so it's like, here is this in Haskell, here it is in Rust, here it is in Go, right? And start showing them as side-by-side comparisons, saying this is IOGs, but this is how, you know, or whatever. And I'm not necessarily saying it everywhere in everything, right? But, you know, in certain cases where it might make sense. Yeah.
May I quickly clarify my situation here, right? I'm not representing anything of the IoT.
No, I know.
To say.
No.
Personally, I had one experience. I just 2 days ago, I just tried to ditch as much as I could of Ouroboros network from out of our code base in Hydra, right? I was so happy to kind of get rid of some of this code and handshaking and bullshit by just saying, oh yeah, the Cardano API, which is another Haskell library, right? Will just do that for me a bit and kind of give me, okay, I need to use these types. That's it. Kind of get away some of this option space there. But I understand perfectly, and I've been like implementing at least one Ouroboros network type protocol myself, which we're using also in Hydra to talk between Hydra nodes. So did you know that one Hydra node to another Hydra node also talks Ouroboros? Like this kind of type protocol thing. We just tried it out, but it's basically a very stupid type protocol because it's just fire and forget. It always just sends out messages, and this basically boils down to, oh yeah, TCP packet. There is some handshaking and maybe some reconnection stuff and so on, but this is basically what we kind of use there. And personally, I'm also so close before, and probably soon will be ditching that networking layer, because now it comes to the point we need to also document a bit. What does it mean to talk to a Hydra node on the layer 2, right? What is the actual messaging format? What are the kind of messages which we kind of exchange? And how could you maybe implement another node, or how can you kind of, no, not gRPC. But probably, let's see, right? So the question is, maybe we can learn a bit from the situation. And I would like maybe ask you guys now, as you have been like reverse engineering a lot, have you built up a knowledge base for yourself, like an API spec for yourself? I mean, kind of, how would you test your code now? You written code, right? And how do you test it against the spec or so? Is something like this kind of emerging, or?
So when it comes to testing, the most likely way we test stuff is trial by fire, and by, you know, testing it out and getting it onto preview or something like that, and actually running, you know, code through it. I mean, that's what we've been doing for pretty much the entire time. You know, testnet before that, you know, and now it's just a preview for testing stuff. But I mean, you know, like with Maestro and things like that, we're running things on mainnet. You know, so it's just been, you know, through running it. Same thing I know with Santiago and TX Pipe.
Yeah, I have my list of peculiar blocks, I call them, and those are the blocks that for some reason the system crashed and I had to go and manually see what was happening. But that was more related to the decoding and the Cardano ledger, which again, I was mistaken. We have CBDLs for those. But on the Ouroboros side, what I found easiest was to just unit test at the state machine level, which those are well documented, at least the official Ouroboros protocols, and the rest, yes, trial by fire and just see if it sticks once you connect it to a actual node.
Yeah, we unit test the messages.
Yeah, because I would wonder what happens, right? Playing a bit devil's advocate here. What happens if you guys just put this into like some kind of open API schema, maybe something which is a bit more like admissible to like binary network protocols, something like that, right? Something which kind of looks fancy, is good and well accepted, and maybe paired with some kind of test vectors or something, just maybe a Go test suite to kind of run by, like play the other side or so and so whatever, right? This would certainly kind of say, oh yeah, we recommend you to document the APIs, right? But did you document what you kind of reverse engineered? Probably not, right? Because you don't see yourself in the
completely fair, right? No,
but yeah, the problem is that yeah, but I think that we can discuss. I'm sure that there were a lot of rationale and discussions behind choosing Ouroboros and a CBOR and a custom TCP level protocol, but to be honest, there's no tooling to describe this, which I know of. Maybe there is, but describing a protocol, an interface definition at the binary level with all these nuances and CBOR, which again, it's not deterministic. If we could have deterministic CBOR encoding, that would be, I think, a huge win, but we don't have it. That's not a requirement. So there is no tooling around this kind of protocol.
Yeah, I'm lacking a bit details here, right? But I'm just figuring out how can we kind of, I mean, actually would be nice, right? Hey, by the way, this is your protocol here, documented, up to date. Are you sure this is correct? Yeah, yes, we are. Are you sure you're implementing this protocol? Oh, I don't know. What is this kind of forcing the standardization a bit, right? Because sooner or later we will have other nodes and other people actively participating in the network using these other languages.
Ethereum has a test bench where you execute a set of integration tests against any client that they have, and they benchmark it, and they it's sort of like an audit that they need to pass in order to become a client. I think that we need something like that, like a black box test bench where we can just put a client and say, hey, this is compliant with Ouroboros. That's as far as I think we can get regarding a valid tooling for this kind of ad hoc protocol.
Yeah, basically by just putting it out into the network, that's the first step, right? But then basically kind of having a bit of an acceptance test thing, right? Because it's only like talking the right protocol is only one step, right? But talking it like efficiently enough so that you can basically become a relay, you can become a block producer, right? Which you would kind of actively participate in this particular system. That is a far more challenging thing to test than later on. But I think, trial and error is also fine, but kind of I imagine the feedback loop kind of be really not nice to kind of think, okay, does it really now sync all the blocks of that network? Yeah, let's wait a bit. Or sure.
And I think I actually had a test bench at some point, but they ditched that. At least that's what they told me.
Yeah, I was going to say the same thing. There was a binary test bench, and it didn't get updated. I think with like Shelly or something like that, and then they just never went back and updated it. So they unpublished it for a while. So
Yeah.
And that was more what we had found was the case for stuff where things were very well defined up until a certain point. To where it's like, oh, all of the, so like chain sync was well defined up until a certain point, like maybe Byron wasn't very well defined, but like everything, after that was very well defined. It was easy for us to do all of that stuff, super easy actually. And then it would just stop to where it's like, oh, there's a new protocol and there's no documentation for it. So we wait until the node comes out. Oh, it's fine. It only has 4 messages. It's easy. But like it was that sort of a thing where it was like we just had to kind of wait and see what we were going to get to implement it.
Yeah, interesting journey.
Yeah.
What are the specs for the Hydra?
Yeah, I'm just asking. I just wanted to ask. Our spec is actually specifying the chain interaction only, right? And I'm actually really missing how would you specify the networking protocol? Like how would you expect the binary message? It should be binary, I guess, right? You want to transmit transactions as fast as possible between Hydra nodes as well, similar to Cardano, right? But we're not in an adversarial setting, so denial of service is not so much of a problem for us. So maybe something stupid like really just sending TCP packets and using some kind of serialization formula and something that works for us. But how would we document that, right? Should I write a LaTeX document, which parse with human eyes all the time? And I need to keep it updated, right, before I change the code implementing it. And I cannot test my code against it. That's probably not the most modern way to do it.
What's the argument against gRPC? Honest question.
Okay.
Yeah, but it's another question. I just want to hear your rationale.
So I can't recall off the top of my head. I mean, I believe nowadays there is like not only specifying kind of endpointing, request response things, but also kind of more like streaming events, pubs up kind of primitives, I believe, but I'm not super sure. And I think there was something. Is it a self-describing plot? Maybe you can quickly summarize why you think gRPC would a good fit. I mean, it's a self-describing with some
not self-describing. You need a EDL, IDL somewhere else, but that's once you define that, you get documentation, you get clients for many languages, and it's quite performant at the binary level. It uses the same dynamic integer encoding depending on the size, all that stuff.
Okay. It only does it only specify message formats and like framing things and like binary encoding, or is it also about how connections are established, how maybe some
you have to
patterns queuing and so on? Or?
Yeah, you have 2 layers. I think that Andrew and Chris probably know a lot about this too, but there are 2 layers. You can define messages with a proto syntax, and that is a binary encoding serialization mechanism called protobuf, and you can use that if you wanted to just serialize the messages, and that's a good way of describing them, in my opinion. And then you have another layer, which is gRPC, where that describes a mechanism for connecting 2 parties and how to multiplex connections and framing and retries, etc.
Yeah, I know protobuf, so I also see that a bit separate, but yeah, okay. And yeah, I mean, we need to look into things again. Right now, it's really just it's a CBOR on a Ouroboros network, right? Like on a type protocol. That's why it's probably interoperability is not going to be great. Yeah, right. We see this just story here, and yeah, this is a resource.
So that's actually that's all the CDDLs. They're now all documented in here, which is. If this would have existed when we started, would have been great.
Oh, this is
nice.
Santi's like, oh,
where was this 12 months ago?
Yeah.
So, like
exactly.
I said, a lot of this has improved. But I mean, if you go and look at the history, these are newer than 12 months old. Or
5 months.
Right. So everyone's like excited now. So this would be great. you know, like for network layer, even just these CDDLs would be a good starting point, right? Because now we can build on top of it. We can have communication about what the like what the contents of the messages look like, instead of just what are the messages and that sort of thing, right? Like
peer sharing protocol. That's a new one for me.
The peer sharing, yeah, that's the gossip. That's going to be in the next version, right?
Yeah,
that was only
P2P stuff, right?
merged like 3 or 4 weeks ago, I think.
Have you implemented any P2P networking stack on the Go side, guys?
Not yet. We were mostly waiting for this peer sharing protocol. They called it peer-to-peer gossip until like a month ago. But yeah, we've been waiting for this.
Yeah, so we're planning on implementing it. There actually, someone had implemented a Go P2P that worked just the same way, reading from the ledger and all of that stuff using ChainSync a long time ago, like before we even started working on Go stuff. There's a Cardano-P2P. It's written in Go, and that's all it does. Is it actually would produce topology files. Like, so it was before, the node actually had P2P. So it would produce topology files entirely from the blockchain and be P2P. So that was how someone was getting away from not using like the topology updater, just using the blockchain itself to pick their peers.
And who are the guys behind that? Are they still around, or?
I don't think so. Let me just give me a second. Let me see if I can find it. Yeah, maybe. Regal, I think he is still around. Sebastian Legger. Here.
So many people called Sebastian.
I know.
I always. Oh, what was it? No, wrong surname. And then you need to think about the pronunciation, like Lega and Nagel, and if you like pronounce it in English, and okay.
But yeah, so it's this one was kind of interesting, right? And this was designed, like I said, to spit out a topology file. But I was planning on using that plus, the peer discovery, and using that to add essentially P2P support with peer discovery. So new protocol, yeah.
Okay, so protobufs are in favor. Okay, interesting. And what kind of connectivity? We need, ideally, we would need multicasting capabilities, but right now it's point-to-point. And ideally, some brokerless message queuing stuff to kind of increase a bit like quality of service of this like delivery, right? So kind of have some kind of queuing we don't need to put in our application.
COMQ.
Yep,
like an interesting
that's also my
one
thought.
too.
I also thought of CRMQ in the past, but they kind of just evolved this all over time and time again. Let's see. I once built a messaging middleware, basically doing very similar things, like a descriptive messaging, like also service endpoint, similar like gRPC. It didn't really exist back then. It was about 10 years ago, 8 years, something like that. And we built this kind of description format, which was also a thing in robotics. And like you have this ROS, which is like topics of messages you can subscribe and pub sub and so. But this was not self-describing, and we needed something self-describing for our purposes to make things a bit easier and better. And we had this kind of description language, and then kind of serialize it in one form, and then also the communication. What's it called? The transport itself was then using CRMQ for kind of some very basic submissions.
I remember Ross. I used it in another life. Yes.
Yeah, I kind of. I think you spoke about it, and like, yeah, it feels different here. You're right. robotics. I think we can move on the agenda. We start chatting.
Yes, we have 10 more minutes, so I think we have just one more thing on the agenda. I think it's just to tie the knot on the last thing we talked about last time. So yeah, we talked about adding tags to tooling, developer tooling on Cardano to know what is compatible with what version. We made a decision to look into maybe we use the dev portal and augment it with that kind of compatibility information. Santiago, do you have time to kind of look into this and do you have any updates?
Well, yes. Matthias Bencourt had already some work on this front, so I'm piggybacking on that one. He had a summary of dependencies between tools, so I'm looking into putting that into some descriptive language, probably YAML or some JSON, so that we can have a specific place where we can update. I'm not pushing forward for a standard, just something, some small data model that we can send to the developer portal side so that we can then render something like a compatibility matrix, where it says this one and this one for this version and such things. On that front, on the developer portal front, I need to contact Philippe Aikevix, I think it's pronounced, with a summary of the idea to see how that can be included into the UI and rendered as part of the documentation.
Okay, very nice.
So still ongoing. I can maybe share something of this file containing the data once I have it. It's not going to be the final version, but rather something that we can share around and see if every tool provider can chime in and complete the compatibility.
Okay, and so it's just adding kind of metadata around what node version that tool is compatible with.
Yeah, and right now the idea is to have one file, a single source of truth that we can send to the developer portal side so that they can update that. But probably after that, we should think in some PR-based workflow where we can just commit changes to that same metadata in the developer portal side directly.
Perfect. Yeah, great. That would be great for everyone. So yeah, let us know how we can help. We'll definitely review it when you have a draft, and we'll try to push that to the portal.
Yeah, sounds good.
Okay, well, I think that's it for the agenda. We just have like about 5-6 minutes left. We can maybe, the next call is probably gonna be in a month, right? I think a monthly cadence sounds to be the right amount of repeating cadence. We already have 2 topics that are potentially on the table. So Arno wanted to talk about Mithril, which could be interesting, and then Values wanted to talk about also gRPC node interface. So we talked a little bit about that today as well. Yes, Values?
I think Santiago should talk about that, not me.
We can share what we have and see if we can collaborate.
Okay.
Yeah.
If you're working on something, for sure we should try to sync to see if we can align efforts.
I'm not actively working on anything yet, so that's why it's much more fitting for you to present what if you have anything. I think that'll make more sense.
What is the bottom line of this? May I quickly ask, because it's just also interesting, Cardano node, right? We aim to be a bit similar, layer 2 Hydra node, like gRPC interface to the Cardano node. Can you maybe describe in one sentence why, how, or maybe just why?
Why? Because of all the things we discussed previously regarding the problems building a client. Now with gRPC, the client is just auto-generated by default, and the specs are auto-generated into a markdown document that you just published. On my side, I'm working on it for Dolos, which is a project that tries to have a like a trimmed down version of the node that only uses chain sync from a relay to keep a local version of the ledger very optimized for just delivering that to the outside in both Ouroboros and gRPC.
And you would basically imagine that the gRPC is then used to ledger this kind of a query this ledger state, or kind of do you have some endpoints for answering these queries rather than
it's not a
specific
one-to-one mapping. Yeah, it's not a one-to-one mapping with all the Ouroboros protocols, because I think there is a room for optimization when you're dealing with a client implementation, not for consensus, not for peer-to-peer. But for client, I think there is a room for optimization and adding some interesting queries that would improve developer experience, like, I don't know, resolving the UTXOs for inputs when you query for some transactions, so you get everything in one call, that sort of thing.
Yeah. Okay, yeah, that sounds interesting. I would like to kind of also hear what kind of development this goes into, because it's, as I said, a nice indicator to what somebody seems usable, maybe on the Cardano node, on the Cardano layer 1 layer already. There are some things that are different on layer 2, but basically, in a way, as closer this is, right, the better the compatibility also.
I can show what I have. And yes, Praderes, if you are also working on something, or if you want to share that presentation, by all means, it's something we can talk about.
Sure.
Okay. Okay, so I'll add you to the list. Yeah, I mean, these are both interesting topics. I don't know if we can split the meeting in half, or do like this one, we just do one call of 1 hour. We'll see, because since it's only a monthly cadence, right? Either it's next month or it's in 2 months, which could be quite a while. But yeah, I'll just make a poll on the Telegram, and people can vote on what they want to hear next, and then we'll go from there. Okay. Yeah. Any other comments or things you want to mention? Yes. Sebastian, maybe can you send me your Telegram and I'll add you to it. Yeah, if you're not in the Telegram, just send it to me.
Yeah, I need to get started using it. I only use it with my phone number and not even have a handle or something. So old school.
Yeah, we went with Telegram. I don't even know why, but right now
that's okay.
Yeah, we have it on Telegram.
Good.
Okay. Well, yeah, thank you everyone for coming. This was a very interesting discussion. I think we had the right people in here as well, between Santiago and Andrew and Sebastian. I think this is extremely relevant. So yeah, looking forward to where this is going. And thank you again for coming, and have a good day. Talk to you guys later.
See you.
Bye, everyone.
Bye-bye.
Bye-bye.